Thank you all very much for coming. It's much nicer than it was yesterday, but I know some of you were in the talk yesterday, so I will do three separate introductions for Chris. It was a very brief one yesterday, fairly brief today, and I'll do a more substantial one with some slides tomorrow. But huge thank you for being here, Chris. Thank you for your time and for delivering the presentation today. So for those of you that don't know, Chris's research background is in vascular physiology. Chris has done some fairly extensive work over time, but starting out at Penn State for his PhD, move into the Mayo Clinic in Minnesota for his postdoc, working with the likes of people like Mike Joyner, so pretty good pedigree. And has spent the last 25 years, is that correct, at University of Oregon. Chris works across various areas, so working on autonomic and vascular function, right through to exercise and environmental physiology, both for health and for performance. So he's got a really broad depth of expertise. In terms of kind of research papers, I didn't dare look at the numbers, Chris, but it's a lot of research publications and really substantial research funding from places like NIH and the AHA. So very substantial experience, absolutely honoured that you're here. And yeah, this is Professor Chris Minson.
Thank you. All right. Thanks, everyone. I'm super honored to be here. This is fantastic. I did a short stint at John Moores University, and there I always heard them talking about this university as well. So I think some good competition on the best sports science program there is. And so I'm really happy to be here. And of course, I've got to know Samantha and Liam and some others and Lewis over the years. And it's been fantastic to know and start put more faces to names and stuff as well. So thank you very much for the introduction. So as Samantha said, I have a kind of I'm easily distracted by bright, shiny objects, is what I like to say. Which means I get excited about something, I dive into it, and I do that for a while, and then I kind of switch to something else. But at the end of the day, hopefully this will all kind of come together. So I want to start. I do have to show a conflict of interest. I'm required by my university to show this. I am the co-founder and chief science officer for a company called NatureQuant. And I have to say this really before most of my talks, and this one especially because I'll be referring to that later, so that'll make sense in a little bit. So just to give you a picture of where I am from, this is our new, the historic Hayward Field. I put it in quotes because the actual Hayward Field was one of the most famous track and field events in the United States and maybe even the world, was wiped out. And then they built this new one for us to host the World Championships, the first time on U.S. soil that they had the World Championships. And luckily enough, the one corner you can't see there is actually my corner where my lab is, and so we got a lab space into that really northwest corner, if you will, of that stadium. So really state-of-the-art facilities, and it's been great having some of you come visit us there and seeing what we have, and then now me seeing what you have, because you've got some fantastic facilities here as well. So I see the parallels are fantastic. Again, I at the end of the day, I'm a cardiovascular physiologist, but I really have worked in a number of different areas, mechanism of cutaneous vasodilation, how skin blood flow works and sweating, environmental stress, acclimation, exercise performance, and the health benefits associated with that. I'll be talking about that more today. It's on the thermoregulation kind of side. And then this, as I've spoken yesterday, the female sex hormones, vascular autonomic regulation, as well as some treatments of endocrine and gynecological disorders. So it seems like I don't have any idea what I'm doing. I'm bouncing all over the place, but really I'm a cardiovascular physiologist at the end of the day. That's what links me, and that kind of makes sense here. So I want to talk a little bit about the health challenges we're facing as humans. You all know this probably as well, if not better than I do. Some of the underlying mechanisms of cardiovascular disease, so we're kind of all on the same page. And then kind of briefly talk about how does exercise improve health? And everyone here knows that pretty well. And then I'll talk about how heat therapy kind of links in or relates to that. And then I want to talk a little bit about the health impacts of nature exposure and why that's important. And then I'll just touch briefly on cold exposures, because every time I talk about heat, people say, well, what about cold? And I don't know if you guys heard of TikTok, but apparently everyone on there is doing cold stressed and cold plunges, and everybody's is way healthier because of it. So we'll talk about that briefly as well. So the way I kind of look at things as an environmental physiologist, cardiovascular physiologist, is that at the start, we were single-celled organisms floating around this primordial soup of the ocean, right? And at that time, we were just really impacted by the environment that around us. So we have the ocean changes, where we float, where we come on land, whatever it was, we're surrounded by the environment, impacted by the environment. Now you fast forward all the way up to kind of where we are today, we're still greatly impacted by the environment, hugely, right? if you look back even just a few thousand years ago, this is kind of how we lived, right? We were living outdoors. We were, hunting and fishing and gathering and getting food from outside. We're living outside. We're having to kill animals and wear their skins to keep ourselves warm. But then even just 100 years ago or less, a lot of the world was living, our countries, the United States and England, of course, in the rural areas. People were living in outside of big cities. They're living in these homes that didn't have central heating, didn't have central cooling, spent a lot of time outside in nature around it, right? And so, but that's changed. We are now in what's called the urban century, right? We're living in an environment that's drastically different from pretty much, like to put 99 with a bunch more nines% of human history than we ever have before, right? Our big brains are allowing us to be more comfortable. So we spend 95% of our time indoors, and 50% of Americans don't even go outside for activity or exercise. And that's probably an underestimation, to be honest with you. Okay. The average child spends just 4 hours a week outside, and that's a little bit older number too. I saw some more recent data that suggests even lower than that, right? That's such a small amount when you think about it, right? Now I know that I'm speaking to choir here. You all have, those of you who have kids are probably getting outside and exercising, but this is how the rest of the world outside of the exercise science world are acting and behaving, right? So what we have done is we've created a situation where if it's really hot outside, we cool our house down, then we get into our air-conditioned cars, we go into our air-conditioned office. If it's really cold outside, same thing, we crank the heat up, we go to our comfortable homes. We're really not exposed to environmental extremes at all, right? Very, very rarely. And so I think we're really living in this thermostasis, right? We don't want to feel uncomfortable. We don't want to be cold. We don't want to be hot. And I think that's a problem for us. And I think that's changing our physiology in some ways. Modern humans, right? We're connected to each other more than we ever have been, right? And yet we're more disconnected from each other at the same point. We live in these cities that often have these very right angles. There's no real natural environments. A lot of the world lives in that kind of situation, right? Loughborough University is beautiful. I love being on college campuses. They're almost always beautiful. But a lot of the world lives in this, right? It's very, very different from how we've been. And then we got, I've been traveling with my wife, and you go in the airports, you look at people, and everyone's got their face in their phone the whole times, right? We're connected to all these people, all traveling on the tube or the train together, and yet no one's talking to each other. Has got their face in their phones, right? So we're connected but disconnected in so many different ways. So it's surprising that mental illness, depression, anxiety are really, really high. Not surprising at all, right? So what's going on? Well, if you look at the United States, this is all up to 2017, this data here. But you can see that the rates of depression, the other mental illnesses have been greatly increasing. I stopped here because this is pre-pandemic, obviously, right? So even pre-pandemic, things were getting bad, especially for the younger 16 to 19, 22 to 25-year-olds, right? Those are the ones at the highest rates. But even the older generation, still 5% of the population has anxiety and depression. That's a lot. It's a lot of people, right? Of course, the pandemic made it worse. I think we've all seen data like this showing that the anxiety disorders and depression disorders have all gone off the charts during the pandemic. And we'd like to think, well, post-pandemic things got better. These numbers are starting to come down a little bit, but they're still really, really high. Okay. And what's complicated is that there's more and more people going on antidepressants. So it's like, well, they're not depressed anymore because they're taking medication, but they're not considered depressed. So where are the numbers coming into, right? So this is kind of a startling number as well. 1 in 5 U.S. teens experienced depression in 2023. 1 in 5. That's a lot. So there's something going on that's making people stress. And again, talking to choir here, you kind of know what some of those factors are. So as a cardiovascular physiologist, I know we cannot separate out the mental anxiety, depression, chronic stress from the cardiovascular disease. They're part and parcel of each other, right? And then the cardiovascular disease makes things worse, and it leads to more anxiety, depression, chronic stress, all these things. So they're very, very interconnected. And as a cardiovascular physiologist, I have to remind myself that I can't forget about this, few pound organ in between my ears that creates so much of the unhealthy situations that I have. All the stress and anxiety comes from our brains. So kind of the background of what I'm trying to say here is that I think humans have become too physically comfortable, too mentally stressed, and too removed from nature as well as from each other, and that's creating problems for us. I think it's a problem. So the question I've been asking in my laboratory has been, can we use environmental and or nature exposure to target modern diseases? Again, you all know what modern diseases are, right? For me, as a cardiovascular physiologist, it's great that cardiovascular disease is the number one. Help us get funding. It's not great for everybody who has cardiovascular disease, but then cancer, respiratory diseases, diabetes, Alzheimer's, it's kind of they're all there. And of course, obesity and diabetes are major contributors to this cardiometabolic disease, and they're all linked to Alzheimer's disease as well, right? So this is kind of where the mass number of at least Americans right now are looking. These numbers aren't changing a whole lot, unfortunately. So what mechanisms underlie cardiovascular disease? I'm kind of putting this up here just as a, again, most of you probably know this pretty well, but we know that things like aging, hypertension, physical inactivity, insulin resistance, obesity, cigarette smoking, hypercholesterolemia. If we did a poll, we'd probably come up with 10 other things that all kind of relate to this cardiovascular disease. And a lot of it is happening through vascular dysfunction, a dysfunction of the blood vessels, and those can lead to heart failures and other things that are all cardiovascular diseases. So they're all kind of related to vascular dysfunction. When I think about vascular dysfunction, we think about the endothelium, that innermost layer of the blood vessel that releases all these important molecules, right, that are known associated with healthy blood vessels. And then we're talking about arterial stiffness as well. So these are the two things that we've kind of focused on from a health perspective in characterizing how much people, how unhealthy they are from a cardiovascular standpoint and what we can impact. And so what leads to vascular dysfunction? Well, we know that oxidative stress and inflammation are these two really big things we hear about. This chronic low-grade inflammation, also oxidative stress, right? We know that they can feed forward each other as well. If you have a lot of oxidative stress and it's chronically activated, which we'll talk about in a moment, can lead to more inflammation. The inflammation can lead back into create more oxidative stress. Now, there's a lot of pathways by which these things impact us. The one that we focused on the most probably is, I say we, my lab, but also most labs have really focused on nitric oxide. But I want to be clear, there's a lot of other things that are involved behind this. But nitric oxide seems to be one of the real players that when that's really disrupted, things kind of go pear-shaped completely from a health perspective. So a lot of work's been focused on nitric oxide. So how can we prevent cardiovascular disease? That's a question for the group. What can we do?
Exercise.
Get outside. What's that?
Exercise.
Exercise, right? That's a quick answer. You'd be surprised sometimes I give talks, people are like, what can we do, right? Stop smoking. Yes, absolutely, right? But exercise. And no matter what I say today, the most important thing that people can do to prevent cardiovascular disease is exercise. Yes, diet is extremely important. Stopping smoking is important, but in all these contexts, exercise is number one. It's the best thing you can do for your whole body, full stop, okay? So how does exercise help us, right? We know that if you go out and exercise, when you're done exercising, you're more broken down than you were when you started. You've got all these reactive oxygen species going around. You've got this low-grade inflammation or this inflammation happening in your joints and muscles. You can't do as much work afterwards because you just worn yourself out, right? But then you recover. Then you repeat that. Stress, recover, progressive overload type stuff, right? Stuff we all learn in our first exercise science class, okay? Over time, you get this adaptation. So the signals that we get, these stresses we get are thermal, metabolic, hypoxic, oxidative, mechanical, inflammatory, a bunch of other ones as well. This is the ones I kind of focused on, right? And then so those acute activations of these, so short-term activation, activates the stress response pathways. So Hans Selye was talking about long time ago, right? We then create antioxidants. We create anti-inflammatories. We have growth factors activated. We get improved stress resistance and resilience. These all happen from these acute, then recover, and over time adapt responses, right? This is what underlies our performance adaptations and our health adaptations. Okay, so how can we prevent cardiovascular disease? Exercise. But there are a lot of people who don't get the full benefits of exercise, right? Or they just don't want to exercise. That's a very large population of people who just don't like to exercise. Am I right, Liam? Right? Elderly, frail, heart failure, peripheral artery disease, people, diabetes, obesity, Liam, spinal cord injury, amputees, those lacking motivation, all kinds of reasons, right? So we need alternatives. Or even we need things that might add to some benefit. I worked with some spinal cord injury patients, and it's devastating to see how hard these spinal cord athletes work and exercise. And then you do blood testing on them, and they look like an older person doesn't exercise, right? And it's partly because they can't get the full benefits that they get from whole body exercise. And there's a lot of people doing great work trying to figure this stuff out, but it's a problem. It's really hard when you meet these people. So this is where heat therapy kind of came up, right? And let's face it, who doesn't want to party with those ladies? I mean, that just looks like fun to me, right? Hanging out in a sauna with them. Okay. So the idea is like, so how do we get from heat therapy saying this is going to be helpful and then adjunctive or alternative to exercise, right? Well, heat stress is a form of stress. So repetitive acts, acute effects of that stressor can drive physiological adaptations. And what I'm talking about here is like exercise with heat stress, you increase your heart rate, your cardiac output goes up, your blood flow patterns in your blood vessels and throughout your body change. You get increased shear stress, that increases some nitric oxide. You get beneficial vascular remodeling. Okay. You also get an increase in body temperature. You cannot exercise without your body temperature coming up. Very hard to do. It's possible, very, very hard to do it. Right. We believe this activates, very aptly named in my case, heat shock proteins. Get activated by exercise, activated by heat stress. These result in cellular adaptations. Okay? We also get acute reductions in blood pressure following heat stress. We also get increased mood, depressed anxiety, improved mental health. One of my colleagues, Ashley Mason, in San Francisco, she's really focused on how single bouts per week of significant heat stress are improving depression and anxiety and other things. It's shocking how much these differences are coming about. Very early in her research, but things are looking really, really promising. Animal models have shown it too. Really interesting stuff. So how have we studied this? Right here are the different subject populations I've focused on. One is the sedentary, okay, people with hypertension or high blood pressure, obese individuals, especially in the context of polycystic ovary syndrome. We do have one study going on non-PCOS obese people with obesity, sorry, and the elderly, okay, work in all those areas. And so in these two groups, the hypertensives and in the older individuals, we're also looking at some biomarkers of Alzheimer's disease. A colleague of mine, Paige Geiger at University of Kansas, is doing some more fantastic work, and she's really leading the charge on that. So I'm excited to see where her work goes. She knows much more about than I do, so don't ask me any questions on that. So how do we study this? So we either randomize or, depending on the study, assign groups to an experimental group or a sham group, or time control sometimes. We then look at their physiology, and again, I've mostly focused on cardiovascular and metabolic, but we're looking at all these different substances, right, or biomarkers: endothelial function, arterial stiffness, blood vessel thickness and intermediate thickness, 24-hour ambulatory, as well as in-clinic blood pressures, oral glucose tolerance tests, muscle sympathetic nerve activity, adipose and skeletal muscle biopsies we've been taking. We then also look at different biomarkers from their blood, as well as we harvest endothelial cells from them, or we grow human endothelial cells and then stress those cells. We then do in vivo and ex vivo measures of heat shock proteins and look at all these inflammatory markers and oxidative stress markers, and even looked at things like hypoxic tolerance. So we do that, and then we put them through some kind of heat events, right? So usually about 8 to 10 weeks, 30 to 36 sessions of heat. So we're really just mimicking or stealing from all the exercise literature, right? And we've used hot water immersion, or whirlpool, and we've done both dry sauna. We've got some far infrared sauna stuff going on. We can talk about the differences there. And then we bring them back and test them again. We usually do a start, a midpoint, about 4 to 5 weeks, and then at the end as well. We don't oftentimes do the full battery of everything in that midpoint because it's expensive and super time consuming, everything else. So we try and get these pre-post in all those, and then try and get some middle points as well. Right. So that's been kind of the model for all the data I'm kind of going through and show you. I'm not going to show you a whole lot of data actually, but so you have to kind of trust me on this part here. What we've seen is reduced blood pressure, improved endothelium-dependent dilation. That's in both the conduit vessels, like we see in the brachial arteries, our proxy for coronary arteries, as well as in the microvasculature. We've used the skin primarily for that microvascular work, but we've done some forearm microvascular stuff as well. Reduced arterial stiffness, we measured it multiple different ways. Reduced intermediate thickness and lowered sympathetic activity. This is not in every population of subjects in every study we've done, but we're seeing in really every study that I'm talking about here, we've seen changes, okay, and improvements. And the bottom line is we have robust improvements in cardiovascular health in all these due to all these markers. We're not studying people for dozens of years to really look at whether they get disease or not. I'll come back to that. Okay, metabolic side, reduce inflammation in adipose tissue that we've taken out, right? Improved insulin signaling in both skeletal muscle as well as adipose tissue, and improved glucose and insulin signaling in glucose regulation. So again, some pretty robust changes in metabolic health. And this is all in people who are not exercising. Okay, so we're seeing these improvements without exercise, which is pretty profound in a lot of ways, I think. Okay, so a great question that I get a lot, and it's an absolutely fair question, is do these improvements we see in biomarkers of vascular function, metabolic health, do they translate to meaningful reductions in disease or death? Well, luckily, we have some great studies by like Jari Laukkanen, he's in Finland, have done some fantastic work where they did prospective studies. And there are a lot of incredible things from this very powerful data, but also some limitations to it as well. But in this case, they followed 2,315 middle-aged Finnish men and women, and I had this asterisk here for a long time, so I was very angry they didn't have any women in there. They have now published a bunch of data in women, which is great. And it's all part of the Finnish ischemic heart disease study. And they have these graphs they've shown, these cumulative hazard graphs. And if you aren't familiar with these, that's okay. Just know that on the x-axis there, they've got the follow-up time in years. So they enroll people, and because it's Finland and more like what you have here, they can track these people for many, many years and see what diseases they have. They can see when they die. And this hazard is based on deaths. So when you see these numbers changing, that's based on people dying, like gone, ceased to exist, 6 feet under, well, sorry, 2 meters under. Not sure how far you guys dig them, but this is people dying, right? So they looked at sauna frequency per week, and there's no zero here because pretty much everyone in Finland uses sauna. So there's no control group here at all, right? You got like, I think 1 sauna for every 4 people in Finland. There's a lot of saunas there. Okay, so if you have someone who's going to sauna 1 time per week versus 2 to 3 times per week versus 4 to 7 times per week, the risk of your death when counting for everything else they can account for, which is not everything, because they only study them at enrollment and socioeconomic status changes, people's things change. They had the enrollment data and see when they died. But pretty profound, powerful data that sauna use was associated, again, controlling for a lot of other variables with improved health. They also looked at how long they sauna, less than 11 minutes, 11 to 19 minutes, greater than 19 minutes, massive reductions, right? So more and more often seems to be better. Right? There's, I'm sure, an upper cap of that, and we've kind of pushed those limits on a couple of our studies, right? But really a 48% reduction at 30 years of deaths, okay? That's massive. That's massive, okay? So bottom line, the frequency and duration per session of sauna use were associated with reduced cardiovascular related mortality, sudden cardiovascular death, hypertension, and Alzheimer's disease. These are all separate papers they've had, so I'm kind of summarizing here. Really, really interesting data, really, really important data from what we've seen. Very hard, you can't replicate that, right? This is just gonna be one of those things. So I want to talk a little bit about one of our really big clinical trials. This is, a very expensive clinical trial. We had heat therapy versus exercise training. And the goal was trying to lower blood pressure in people with stage 1 and stage 2 hypertension. And we looked at 30 sessions of supervised heat therapy and exercise training over 10 weeks. All our other studies, we've seen great improvements. We're really excited to do this. Got lots of funding to do it. Real big team to go after this. We looked at all these different factors here, a lot of some new ones we hadn't looked at before, kidney function, clinical blood markers, all these things. And people were either enrolled into heat therapy or exercise. People say, why don't you do a control group, time control? Well, we wanted to, and the reviewers kicked that out. They didn't want to pay for more work. And everyone said, well, exercise is the gold standard. So we know that if we can do anything close to exercise, hey, it's a win, right? It's a win. So, and you're all waiting, well, what did you find, right? Heat therapy was equally effective as exercise training, improving biomarkers health in every aspect. Come on, guys, come on, let me hear it. Yeah, right, something, right? Until you look at the data. We didn't see any biomarker of anything change in the heat therapy group or the exercise group. That was $1 million of US taxpayer money that I blew completely by showing absolutely nothing. We did every technique at the very best way that we can do it in my laboratory. We didn't see any benefit in these individuals. we were shocked. I like cried myself to sleep for weeks, just thinking like, how do you write a grant on nothing? The next thing will be this, right? So this was a challenge. So a few points here became really salient to me, right? One of them is, why do we not see these benefits? If we had had a control group, a time control group, what might we have seen? What's that?
Increases.
Increases. Well,
Blood pressure.
right, yes, right. They might have gotten
They
worse.
get worse.
Absolutely right. They might have gotten worse. So that was one thing, but we didn't have that, right? In all our other pilot studies and all our studies where we had a control groups, they kind of stayed steady, but they're not as unhealthy as these people. So that was part of it. And then I think so. We did start this before the pandemic. We had to stop it, and we restarted as soon as we can after we were really restricted how long we can study patient groups. And once we got things going, we got people going again, and it was really a challenge because right after people starting to see each other, everyone's masked up. There was a lot of anxiety and stress around, right? So we think that had some that I've talked to a lot of people around the world who have labs, and after pandemic they're not seeing the same things they saw before. They're having a hard time repeating what they've done. This is not unique to us in Oregon. A lot of people have. Maybe some of you have seen it too. Something has changed fundamentally. I think another part of this that may have really changed is that when what we saw in some of the patients, that's because we were working with them all day in, day out for all these sessions, right? Over 2 years, 2.5 years, probably 3 years, I should say, to collect all the data. You get to know the people pretty well. A lot of them do have this, they have this new license because they're doing something healthy. They're exercising or they're doing heat therapy, they're being healthier. So they use it as a justification to maybe walk less. I'm not going to go walk because I'm doing this healthy thing. I'm going to eat worse because I'm doing these things. So there's all these factors that we're trying to understand what happened, right? I wish I could say, look how improvement things, exercise and heat, but it didn't happen, right? So we're really still trying to work on what is going on. And so, part of I think what's happening, especially during the pandemic, but this has not changed for a lot of people, are these cycles of daily stress. So, right, we are just inundated constantly with information, and people are living more stressful lives, mentally stressful lives than we had before, right? This is a perfect example of me, right? I get up in the morning, I start looking at my emails automatically, right? I'm trying to see what's happening. Then I try and do a workout really quick. I'm trying to do it really fast because I want to get out to work, right? But then I'm shoving some food down my pie hole, trying to get some food in because I got to get to work and whatever. Then I get to work and I'm stressful trying to get things going and rolling. And then by the time I get home, I'm eating some food and I'm finally going to lay down in bed and I want to look at the news I haven't looked at. So I have this blue screen in my face and then I'm looking at this stressful, I don't know if you guys are aware, but some stressful things going on in our political stuff going on in the United States right now, right? I don't care what side of the spectrum on you're on, it's stressful. So where's the recovery? So from the very start, I was saying we got to have this stress, recovery, stress, recovery, stress, recover, positive adaptation. Now it's stress, 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 stress. There are different stresses, heat stress, exercise stress, but now it's mental stress, family stress, political stress, life stress, right? It's happening. So what can we do, right? I'm not a psychologist, but stress without recovery results in lack of sleep, poor nutrition, mental stress, anxiety, illness. Those other acute biomarkers that I've talked about, now they're chronically activated. All those stress responses are chronically activated. You got chronic activation in reactive oxygen species, chronic inflammation happening, right? Low-grade inflammation is all over the news, right? Disrupted blood chemistries, elevated cortisol, chronically elevated. You can measure people's hair growth, right? It's chronically elevated higher than it used to be. Okay. Chronic sympathetic overactivity. These are all resulting in poor performance, poor mental health, and poor physical health and disease in a large part of the population. We think this is part of what happened to our study. Why didn't exercise, forget heat therapy for a minute, why didn't exercise make these people healthier? It's hard to move blood pressure, I admit that. But all other vascular measures they measured and we do a really good job with didn't seem to make a difference, right? So these stresses don't go away. So what can we do? And this is where some friends and I started really looking about nature. And we thought we're going to look at nature. And this came from a buddy of mine, Jared. He's our CEO. He was out, he was an adventurer type person. He was out walking in the woods one day and he's like, I always feel so good when I come out here. Why is that? So we started talking. We thought, well, we should start studying, start seeing what is there any benefit of true just being in nature? Can we isolate nature health of benefits? We started looking into literature and we're like, there's actually hundreds of studies on this. So like there's a whole area of this research I was not aware of, despite being a big outdoors person, right? And so within 20 minutes of going to nature, a true nature environment, blood pressure drops, heart rate variability improves, right? More parasympathetic, less sympathetic. Levels of cortisol and norepinephrine in the blood can drop. Measures of mood and anxiety improve. Some great happiness studies where they say, start asking people on their phone, just ping them and say, how happy are you right now? And you answer a question, I'm happy, I'm not happy, I'm, whatever. And they found that when people are outside in nature, they're happier. Even they go back somewhere else and they're stressed again, at that moment, they're happier. Okay? Sleep gets improved. All these studies have been published. I wasn't aware of this, right? As an exercise physiologist, you'd think I'd be a little more aware of this, but I wasn't, right? The key though is you need to put your phone away. Some of the data have shown that if you're now checking your phone, you're walking home, and of course, this is great, wow, right? And you see it all the time, right? Students on campus, beautiful campus, and they're bumping India, right? And faculty as well. You can disrupt the whole benefit if you're not consciously aware of what you're doing. So this is all kind of part of this biophilia hypothesis from E.O. Wilson, which is like humans possess an innate tendency to seek out connections with nature and other forms of life. So going back to my first slide is like we're part of nature. We need to be immersed in nature, and there's some real health benefits of part of the human experience has to be connected to nature, and we're disrupting that. The Japanese government has put a lot of money into this early study where they created this park and encouraged some people to do forest bathing. That's just going out and being present in the forest, not going out and getting your tablet and playing the New York Times video games or games or the or Pokemon Go or whatever kids are into these days. It's really immersing yourself like a form of meditation out in nature. And it was so successful that they've created parks all throughout these big cities to try and get people to, and it's being really accepted as a Japanese culture as part of their new culture to do this, right? So, and the bottom line is that nature equals health is backed by hundreds of published studies, right? Really, really fascinating stuff. So, like how much, when, what can I do this? There's actually some more data on this than there is even for heat therapy, if you ask me, right? Is that Rachel Hobman, a neuroscientist at Northwestern, she's come up with this 25-3 rule. There's other values out there, but this is a good starting point, I think. And she says you really should get into a natural environment at least 20 minutes, 3 times per week. Doesn't sound like much. I think most people can do that, right? In some way, right? Spend 5 hours per month in a semi-wild environment, meaning getting away from a city, getting some kind of, or it can be in a city, in a park, but really spend some time there. And 3 days per year, as much off-grid as possible. That's hard to do. It's hard for humans to put your phone away and actually do it, right? So going someplace or as parents, making sure your kids aren't on their cell phones and other things. This is kind of what she's saying is like, this is one of the keys, the minimum dosage you want to get some mental health benefits. So I think it's a good place to start. And so one of the things that we've done at NatureQuant is we created an app. I'm aware of the fact that you've created an app to get people in nature. So right, seems like irony or stupidity, one of the two. I'm not sure exactly what that is. But we were trying to say, like, well, how do people know how much they're getting and how can they be reminded to go out there? So we created this app called Nature Dose. It's available in North America. It was supposed to be kicked off in England, in the UK, and Western Europe yesterday. I was really hoping it's going to happen. It's going to be about a month delayed just for various reasons. But this will be available, downloadable from iOS and Apple and everything else. If you're interested in doing it, don't worry about it. I make no money off this, by the way. Our company makes no money off any of this. It's a completely free app. We're not selling the app. But what it does is we've characterized the environment in about a 1 kilometer grid around your location. And from that, we've looked at about 25 to 30 different factors that are aligned with health or poor health. So big trees are one of the biggest factors that improve your health. Grassy areas are blue zones. The oceans are healthy. Lakes are healthy. Impervious surfaces like concrete are not healthy, right? Parking lots are not healthy. Buildings we're looking at. We have all this data that comes in together, and we've quantified using basically AI and other factors to try and look at the health benefits of this. And we've now had a number of studies who are using our tools in various contexts, and it's the best quantification of your nature exposure that's out there at this point. Again, this is totally free. The thing is, you can't be out there going, ooh, I'm at 16 minutes. I'm at 17 minutes. We want you putting the phone away. And people say, what if I just turn it off and don't bring my phone? Even better. We want you being healthy. Our goal is to make people healthy. Our North Star is have people improve their health through nature exposure. If they do that, they also find out the benefits of nature. They want to support nature. They become involved in environmental practices. It's all part of what we want to try and do. And again, I'm going to be clear. Feel like, well, how much money are you making up? Nothing, right? This is what blows my mind away as a physiologist. I'm not a tech person at all. This silly little app costs about $750,000 to develop, and we're continually putting more money into it to develop it, right? We'll never charge for it for the individuals, right? In research groups, we can do all kinds of stuff where they have people just using the phone, just runs in the background. Weeks later, we can combine their data, or months later, we can combine their data and look where people have spending time, and they look at all different kinds of mental health in children, sleep rates, all kinds of studies kind of going on, and this is one of the tools they're using. So it's kind of fun for us to see that. But yes, you got to put the phone away. Don't take your phone. It's even better, right? We'd love to get in watches and other things, but that's another whole expense. So yeah, happy to talk about that more, but that's kind of the goal. And what's happening here is that we're not, but nature exposure is becoming one of the 4 pillars of wellness: diet, exercise, sleep, and nature. We didn't create this. This is what's being pushed. So I think there's some real benefits to nature that are being unrealized for a lot of people. Again, that's that exposure to what makes us human. Okay, so this is where you hear that ka-thunk, right? And I oftentimes to stop there, but I always get the question, well, are there benefits to cold exposure? And maybe it's cooling down a little bit. See what I did there? Right? Maybe people aren't doing this cold plunging as much that but sure seems like they are. And I get this question all the time, right? And so why would cold result in improved health? Like that's a fair question, right? Well, I know that a lot of the heat benefits come from heat shock proteins. That's only one of the pathways. There's multiple other pathways we can talk about. That's one of them. But heat shock proteins were first named heat shock proteins because they were from cells being exposed to heat, and whether they died or didn't, these cells didn't die. And they were, if you expose them at low levels of heat, then they can give them a toxic level of heat, and they survive that toxic level of heat. And they saw these proteins that are there, and they get activated. Well, these heat shock proteins have been in our systems since we were single cell eukaryotes floating around in that primordial soup. They've been with us since we were a thing, right? They're in every cell of our body. Okay. And what do? Right? So, well, they are not just responsive to heat shock. They're responsive to hypothermia, ischemic stresses, hypoxic stresses, starvation. That may be one of the ways of starvation, or like timed lowering low calorie eating. Well, it's not starvation. That's the wrong term, but very low calorie living, acidosis, viral infections. These things all activate heat shock proteins. Okay, I won't go through the whole pathways here, but just say that these heat shock proteins can get easily upregulated. So we have heat shock proteins in all your cells. They get some stress happens. They then separate from the heat shock factor. That heat shock protein then does multiple things. They help to they acts as chaperones to help keep to carry parts of signaling molecules from one part of the cell to another part of the cell. They bind to proteins to keep the proteins from getting denatured and broken down. If things are broken down, they can actually help them rebuild, like post-exercise, right? But the heat shock factor then actually goes through this trimerization and goes to nucleus and activates even more heat shock proteins. They can be upregulated quite a bit. Heat shock proteins are numbered. This one's HSP70, which is an inducible form. They're named by the number of molecular weight they have, the number of Daltons they have. So HSP70 is 70 Dalton protein. So HSP90, HSP27, these are the ones we've kind of looked at. There's a lot of other HSPs. And again, unfortunately, poorly named for most everybody, but I'm a heat guy, so I love it, right? But they get activated from cold as well, and we think they underlie it. So the question becomes: is Wim Hof, is he legit or is he a kook? Well, in my mind, he's a kook, but doesn't mean he's wrong. Right, he's done some crazy things. He has a bunch of world records for cold exposures. He's the one that's supposedly nearly climbed Mount Everest wearing just shorts, and he's done all these under iceberg swims and other things. But I don't think he's wrong, right? He takes this idea of this hyperventilation, And then it's followed by a max breath hold. But then he does daily ice showers and ice baths. And his large part of it, I think, is his trying to control the mind, quiet the mind, as well as get some cold exposure or stress to the body that then you recover from. And so, again, I don't think he's wrong. What Doesn't Kill Us is a good book by Scott Carney, kind of went into this. There's other books now, too, about him. But as much as you think this guy's crazy, I don't think he's wrong, right? Um, we did one study. This was really, really restricted study on us. The first one we started when the pandemic was being lifted and we could start seeing human subjects again. But they said, meaning the powers that be at the University of Oregon, said, okay, we'll let you do a study with humans, but you could only be, only one person in the room, the subject, and you could only be next to them for 15 minutes out of every hour. And you have to be at least 3 meters away from them. We're like, oh, okay. Just really, am I not going to get COVID if I'm 3 meters away when I get 15 minutes per hour next to them? Like, I didn't, you ask these questions and you don't get answers. So we pulled it off, but it wasn't the best designed study because we had some limitations post-pandemic. But what came out of this is we looked at serum cortisol. We looked at the positive and negative affect. That's just how happy or how sad you're feeling at the time. This is their affect scale here, right? And we looked at endorphins. Endorphins didn't really change, but we looked at people at baseline, 1 minute, 15 minutes, 30 minutes, and 3 hours after the cold stress. Okay. It was found by 3 hours afterwards, right? The levels of serum cortisol had dropped. We did try and do all we could to try and make sure it wasn't a timing circadian rhythm thing. Hard to do, but we kind of did it. But the biggest thing was the negative affect was improved. That means there were people feeling less negative. They weren't happier per se, but this was during the pandemic, but they felt less negative, which I think we called that a win. If you start looking at the cold water immersion and health benefits, you're going to find very, very little out there. So as much as this is a very small scale, limited number of subjects, poorly controlled, yada, yada, you can find 20 different ways to criticize this. And trust me, I have done the same to ourselves. There's not that much information out there. So we saw this as a pilot data. Really, it was a chance for me to have two grad students work on their first project. They come to my lab and then the pandemic hit and they couldn't get any skills, anything else. I'm like, let's come up with something to do, right? So that said, I do challenge my students in my environmental physiology class to start doing cold stress and do these cold showers, do something, have a process by which I put them through we can talk about. And 95% of them hate it. I'm never going to hate the cold. I can't stand it. My wife, Julie, hates it, right? We've been in Iceland prior to this, went to all these hot springs, beautiful places, and there's a cold plunge. I'm like, okay, here I go. And she's like, I'm not doing it. She puts a toe, I'm like, nope. Like, but it's going to help in it. Nope, nope. But some people hate the cold. Most people hate the cold. Every year, I've got about 30 students or so who try this, and probably one or two per year continue doing it. And it's crazy. And I do it. I kind of cycle in and out doing cold stresses, but I hate it. I don't like cold. It hurts. I get in like, oh my God, this sucks, right? And then you come out and I feel better. My positive affect is up. I would be a terrible subject for this one, but I just feel glowing afterwards. Like I've accomplished something hard today. It's good, right? So there's something, again, I don't know if there's a real physiological benefit. There probably is something, those heat shock protein pathways, but I think there's a mental benefit for some people. If you hate it and you're miserable, you're not going to like it. Okay. So the bottom line from what I've been saying and what I'm trying to encourage people to do is for health, we're talking about here, some improved performance I'll be talking about tomorrow. Every day, get out of breath, get hot, get cold, get outside. These things are aligned with health, right? You don't have to exercise. I think you should, right? You can do a lot of other things too. Heat stress, cold stress doing the right way, just going out in nature, you're going to be healthier in the end. And so I do like, there's a lot, these studies are massive. This is not everybody I can fit on the scale, but this is, I got all these people in my lab, I've worked with all these collaborators, this undergraduates, I really have about probably 50 or 60 have helped on these studies. These are the ones who helped with the primary study I've shown you here, right? And lots of great funding. And most of all, thanks to all of you for coming and listening to me for a little bit.